Hi, I'm Thierry Dubois. I'm a journalist. I cover aerospace. I work most of my time for Aviation Week. And I have the pleasure to moderate this panel discussion on the ecosystem to build the aircraft of the future. So what kind of ecosystem should the industry plan on to build future aircraft? The new generation of aircraft will probably use different fuels, different propulsion systems. It will probably have different architectures, different aircraft architectures. It will probably take place, building a new aircraft will probably take place in a fully digitalized environment. So how will this impact the supply chain? In 10 years from now, in 10 years, will the word supply chain have a new meaning? And what about certifying new aircraft? With me, I have Ariane Mayer, who is President and CEO of Embraer Commercial Aviation. I have Colin Mahoney, President of Customer and Account Management, Collins Aerospace. To his left, I have Stéphane Viala, Senior Vice President, Engineering at ATR. Next to him is Eric Schultz. He's President, Consultant, and Advisor at SHZ Consulting. And next to me is Luc Tidgat. He represents the European Union Aviation Safety Agency, EASA, and he's the Strategy and Safety Management Director. Thanks very much for being with us today. Housekeeping rules. I have 3 small signs here in colors for timekeeping purposes. So as you guess, if you are in green, you are perfectly fine. If you are in orange, you are invited to wrap up, and I don't have to explain the red. Thanks for your understanding. To get started, I'd like to delve into supply chain, the supply chain for manufacturing. We'll talk about other supply chains later, but let's talk about the supply chain for manufacturing. In aircraft manufacturing, how should the existing supply chain evolve? Eric, would you like to start on this one?
Yeah, thank you very much. So I think before to try to answer what the changes we have to expect from the supply chain, the first thing is to define the what. So what is the final solution, and what are all of these solutions? Because of course, some solutions will be more impactful to the supply chain than others. So if I pick an example, my personal conviction is that long term, at least for the large aircraft, when I mean by larger, I'm talking commercial aircraft, I think the future will be hydrogen at some point. Now, of course, there is a transition. We have about 30,000 airplanes flying today. And the quickest, fastest transition is to get to biofuel and synthetic fuel as quickly as we can, because that's the only way to transition that 30,000 existing fleet into a more decarbonization, if we want to say so. On that aspect, if the first step of the transition is clearly to change fuel with biofuel and syn fuel, then the changes in the supply chain will be quite small. There will be a lot of changes to manufacture the fuels, but as part of aircraft technology, the aircraft architecture the actual aircraft architecture will survive. The changes will be pushed away for when hydrogen and probably liquid hydrogen will come, which is a completely new game changer. So to your question, depending on how the transition is made and when it is made, we could go from very little changes in the supply chain up to massive changes in more long term. That's my personal vision.
And if we go ahead, if the industry goes ahead with hydrogen, should the existing supply chain start evolving now or in just a few years from now? How early should it?
Yeah. So I think that hydrogen is a completely big change forward, because it can have 2 consequences. One is to use hydrogen as I would say, fuel in turbofans. Turbofans we know. Then the changes will be on fuel storage and fuel distribution, not that much on engines. But as you know, hydrogen can also be declined into fuel cells. That opens the track for electric airplane, and that would be a complete change in the supply chain, including, and probably most and foremost, into aircraft architecture. But I think we have our friend from NIASA, and I think one of the key things is really about how fast can we transition into completely new architecture. I think the world has become risk intolerant. So clearly when we think a little bit about the 1920s, when we created the aerospace we know today, there was an appetite for risk at that time. The appetite for risk today has gone down big way, and that is making the life for certification authorities even much more difficult. So I think one of the key questions for me is how quickly can the certification agencies move forward and being satisfied that the level of safety is acceptable from a public perspective?
Luc, would you like to pick up on that?
Yes, with pleasure. Yeah, I think the question is there, how when industry is pushing to offer new solutions, how we as regulator could we accommodate it and accepting it. We will not, of course, wait. It is ready and mature enough in terms of technology. I mean, we are changing the rules here. And it's more part of what we will calling partnership with industry, and to see how we can see the technology coming before it is submitted for formal certification. So this is really a key element for driving now the evolution of how aircraft will be built up and other technology will be built up in the future that we are getting together. But of course the distance is required because, as mentioned by Eric, what we are looking for is that we are staying at the level of risk we have today. Means almost zero risk. How we do that? By, of course, risk-based approach for sure, but of course we will not regulate into the details what we have done in the past. Prescriptive certificate requirements are not there anymore. We look for performance-based and risk-based. That is probably the only way the regulator could accept the new technologies to be onboarded in the new aviation system. So yes, I think it's another way of working between industry and ourselves, and EASA is preparing for that now. We have already intense discussions, in particular on you mentioned hydrogen and other fuel cell. This is already on our agenda today. We cannot wait. It is done and the technology is finished. Yeah.
Thank you. Ariane, would you like to comment on that, especially on the notion of risk? Of course, in terms of safety, we don't want anything to degrade. We want safety to always improve. But in terms of launching new programs, taking technological risks, or in terms of a slightly more risky business case, would you be ready to go ahead with technologies that are still to be matured?
Yeah, well, let me begin by saying that I hear what Eric's talking about hydrogen and SAF. Embraer acts in the lower segment, up to 150 seats. So we'll also see electric and hybrid, and then we'll have hydrogen fuel cell, hydrogen turbine. So there's even more opportunities that we're looking at. And we have shown to the market several concepts in the smaller segment between 10 and 50 seats. So the big question first is, what is the technology we're going to focus on the smaller segment where there's even more to choose from, right? So Embraer is working on eVTOLs with 4 passengers batteries. We're looking at demonstrators with 10 seats with electric and hybrid. So we're going to be hugely interested in how the regulators are going to approach this as well. There's hundreds of manufacturers at the moment working on battery-powered eVTOLs. There's companies talking about hydrogen. Of course, we have SAF. Let's not forget that before we talk about better fuels, the first and foremost step is to use technology that reduces fuel, because that's something that we never have to offset. So that's why we also need to take into account the timelines that the regulators will need to approve new technologies, and avoid that we're all waiting for that new technology to happen and forget to replace the technology that we already have today by new technology. But the regulators are going to play a huge role, and I think the capacity of the regulators, I just talked to Luc, is going to be a big issue on that, because it's the breadth and the depth that has to develop over the next couple of years.
Thank you, Stefan. Same question for you at ATR. How risk tolerant are you in terms of business case, new technologies?
Yeah, thank you. I concur with what has been said. The regulation time frame is quite long, but not only the regulation for new technologies, there is also the infrastructure, which is very important, specifically for regional market, because we are in the regional market and we are serving regions which are sometimes difficult even to get fuel, you know. So for us, the view, and this is what we reveal when we look at EVO concept, is to pave the way, because it's not a big step that we will do. We'll have to go progressively towards those technology in order to tackle the risk-adverse society we have today. And so the idea is to progressively evolve. And what we are looking at first is the SAF for sure, but we'll have for the SAF to solve the issue of production. So the supply chain will have to adapt as well on this aspect with new players. So which is a different, I would say, value chain that we'll have. And as well looking at how we can develop some technologies in a stepwise and prepare the future by putting some increment, demonstrating and using the platform which are already flying to de-risk the next generation of aircraft. So this is very important that we pave this way, that we work progressively, incrementally with the EASA, with the authority, and that at the end of the day, we define what could be the next big step, but in a progressive way to tackle the risk aspect. And as said, there is plenty of technologies. We are talking about hydrogen a lot. I think hybridization is one way to learn as well, to learn how we can master this kind of technology before doing the big jump, because the big jump you are talking about in terms of business case and in terms of risk will be quite important. So the more you de-risk upfront, the better it is. Another point which is very important is risk sharing. Because what we see today with all the crises we have is an increase of the cost upfront. The raw material is very expensive, the chipset, electronic chipset is disappearing, so the supply chain is suffering a lot upstream. And at the end of the chain, of the value chain, you have the customer, where there is the inflation and he will have less money to travel. And in between, you have the aircraft manufacturer and the airlines. And this is what the equation that we will have to solve. So we have to prepare the future with de-risking the long-term future and tackle the present in terms of supply chain, and to solve this equation, which is a cost increasing upfront and some difficulty buying tickets at the end, which is the end customer. So you see that, it's very challenging and very, I would say, motivating.
Thank you. Colin, as a major systems manufacturer, major systems supplier with Collins Aerospace, how do you see that approach that maybe you will have at some point to take more risks in launching new products?
Yeah, well, our role is to mature the product lines behind this, the vision for this future. So we talk about technical readiness levels, TRL 6 and above, is what airframers really like to see from a supplier as we get ready for this evolution. And I think it is that. I think the SAF environment's the most straightforward, and we see a lot of that today. We have to modify systems to be 100% compliant. But then we go to hybrid electric motors, and we're fortuitous to have both an engine manufacturer and a system supplier in the family. So we're off doing our 1 megawatt motor research and development in what we call the grid. And just that in itself is going to reduce the fuel burn by about 30%. And then ultimately you get to hydrogen. So I think there's these steps on a journey. There's a lot of pluses and minuses said in the market around how far hydrogen is in our future, given the scale of having to carry that on airframes and the infrastructure. But I think we can do a lot of work in the interim through those steps if we're just talking the fuel burn side of things. But there's, as Arjen said, I think there's many more things that we can put on next-gen airplanes beyond just the fuel system that will achieve the goal of reduced emissions.
Thank you. I have another question for you, but this time on the lessons learned from the COVID crisis. When it comes to ensuring your supply chain is resilient, what are the lessons learned?
Well, yeah, we had obviously a pandemic and then compounded in recent times with some geopolitical tension. So I think this experience has been unique to those of the past. You know, we've always had volcanoes and earthquakes. We've had supply chains shut down in different parts of the world. But this one, I think, is going to give us lessons that will become more systemic as we look forward. So I think what I've really observed in this current state is transparency. I see the whole supply chain, whether the suppliers to us as aircraft system suppliers, right through to the airframers, in terms of actually what we need, when we need it on wing. So that transparency, which has not always been there historically, I think is here to stay for sure. And then the dual source environment. And I don't mean two suppliers because that's commercially challenging, but many of us now have dual sources within our own family. So we can't be in a single point failure environment. So I think that's changed probably forever. And then the other thing I've seen moderate is the verticalization. So a lot of companies, whether they're suppliers of systems, airframers, had a vision for verticalization, works really good in growth times, but I think we've observed in this more challenging time that we can actually come together and work well together and maybe avoid the need for some of that verticalization vision we had of the past.
Thank you. Could you define transparency and elaborate on transparency?
Well, so for example, right now I know to an OEM exactly when the load date is for widget X, Y, and Z because we're in a firefighting mode, right? We were fortunate when we went through the pandemic, demand dropped, so we kind of got through that and didn't see the full impact of particularly electronic supply chain. So when I refer to transparency, that build, forecast, and on dock, load date, and so we see a lot more of that now than ever before, which helps us really plan in these times of challenge.
Thank you. Luc, you touched on the partnership with industry, on work with industry to define new rules for future aircraft. What is the right level of cooperation with OEMs? In the end, you decide. In the end, you are the regulator. So what's the right level of cooperation to define new rules?
Yes, I think depending on, of course, what we are talking about, when we speak about an industry which is not really aviation, because this is the case, we are getting more and more manufacturing industry constructing drones or eVTOL, which are not coming from aviation. With this type of actor, we need to really enter into discussion upstream, the full process, in order to be sure that when they want to get certification, I mean, we are understanding each other. What are the expectations from the aviation safety requirements for this type of object, of product? When it comes to, of course, traditional aviation industry, I think this is easier, but not that much when we are coming back to the technology we are referring to. How to deal with artificial intelligence. This is a big unknown for both parties. What industry will produce in terms of solutions in artificial intelligence and what we want to do, it's where we have to develop together. But I think we might be back to that later on. When it comes to certification on hydrogen or on electric propulsion, what we did with the first electric aircraft certified, we have to, before entering the full certification process, to conclude, as I mentioned earlier, partnership contracts. So we are getting together to discuss what would be the level of risk we want to set and what type of mitigation measures we want to set. So we have different levels depending on the complexity of the capacity for us to anticipate that. And another dimension, for example, would be the cyber security. It's also about certifying, and on that also we have to learn from each other. What is coming to the market? What are the risks? What are the threats? What are the level of guarantee we want to offer to the airlines and to the citizens? So we have different levels, and we have created different vehicles. If you want to cooperate is maybe too strong, because we maintain this distance needed in order to be able to judge what is proposed, but not to, because that's what we have understood right now. There is maybe a risk that we take too much time. It's certainly the last thing we want to do. If we want to cope with the Green Deal and this new agenda, we have to be quick. We have to be quick. And this is where, I mean, this relationship with industry is extremely important as well, to see the type of efficiency, the type of certification we want to get on the sustainable aviation fuel, and so forth and so on. So that is done together with it. And you see there no short response to your question. There is different modalities we are offering to industry when they want to engage with us.
Thank you. Arjan, what do you expect from regulators?
Well, from regulators, I think what we need first of all is a speed in addressing the challenges that we have ahead. As I just mentioned, we have different technologies ahead of us, and we're going to need time to develop all of those. We don't know, by the way, which ones we're going to see first. One of the reasons that Embraer went to market with the concept that we presented was threefold. First of all, we see a lot of startups out there that promise the world 20, 30 passenger battery powered aircraft, hydrogen promises, and we've said we want to present to the market what we believe as an established operator, what is realistic going forward. The second objective was to talk to customers about the need in the lower segment, what they actually want to fly in terms of size and range, because that's going to be very important. But the third reason was we wanted to talk to partners, and we really want to understand what can partners do with us in the industry, and of course that's partners across the board. And determining what the directions are and then making progress on that, that's going to take time. So I think the timelines that are being promised in the market, they're challenging, and I think, to Luc's point, we need to be very clear about what we can expect when, and what we can do today. And that's where we're going to need the regulators.
Thank you. Colin, what do you expect from regulators?
Yeah, so obviously we've experienced many challenges in recent times, but I think, and this probably leads Thierry into a topic we might talk to in terms of digitization, but we've got to make it easy for us all to interact. So the, overused word, transparency, the visibility that a regulator has in the very early phases of a development is going to be key to, I think, the future efficiency of certifying airplanes. Because nobody's been particularly proud of the last gen clean sheets, and now we've got a unique pause in the industry. So how do we reflect on the lessons of the past and equip ourselves to do, maybe frankly, what we did back in the 80s, the 70s, where we could seemingly certify airplanes in a much more efficient way. Obviously, safety is a key element. So I think the digitized world of the future is going to help us achieve all of those goals.
Stéphane, what do you expect from regulators at ATR?
Yeah, as it was mentioned, we are facing a real change in the technologies, and for me the first point is to build together the competency. It's very important that effectively we keep this independent view of the regulators. It's crucial, but we need to build the competency, whether on the industrial side, but as well on the certification side, by changing a little bit the approach potentially, and to, based on, you mentioned it, on the risk approach, but more on the safety approach. And we see that the regulation is currently evolving towards this safety approach, and I think it's key when we'll have to tackle new technologies that we are talking about. And what I do expect is that effectively we grow together this competency, and to have the rule makers somehow involved as well upstream in all the research which is done, and there is a program for that, and it is very important that the regulators are involved in this R&D upstream part, because this is where potentially we can drive the technology towards what will be certificable at the end of the day. So we know that it will take time, because the regulation is something which is a long lead time. There is no question on this. I would say, concur with the fact that we have to take care of startup promising the moon, because effectively making an aircraft in the air, or an object in the air, is something which is very easy when it is blue sky, with no wind, with no adverse condition, etc. But the point is to have it operating, and we currently are operating thousands of aircraft in regional world, and we know how it is difficult with the environment we have around the aircraft, around those machines. And this is something that is very important, that we keep this aspect of risk safety for the future technology that will be developed, because it's essential that we keep this level of safety we reached today in aviation. Even so, we do a step change in the technology.
Thank you very much. Let's move to technologies, to the theme of technology. Colin, given the breadth of your product range, can you find technological synergies to make your products more environmentally friendly, more sustainable?
Yes, so just to refresh the memories, Collins Aerospace now is a combination of the Hamilton, Goodrich, BE Aerospace and Rockwell Collins brands. So that really gives us a very unique gift to look at that portfolio and breadth and think about how do we combine them in a way that helps the environmental journey. And I think about it in two ways. It's effective aircraft systems integration, and then it's effective aircraft trajectory management. So we have a role to play in all of that. So if you look at our portfolio, you know, we have aerostructures and we have an interiors portfolio. So those naturally come together in terms of taking weight out of an airplane. That same aerostructures, when combined with Pratt & Whitney and say our propeller business that we do here in Figeac, how do you efficiently combine that to not just take weight out and create efficiency, but noise? Noise is an environmental detractor. So we can take noise out of a system by smartly integrating those product lines. And then when you go to the trajectory of an airplane, obviously our avionics business combined with our connected aviation solutions, and how do we navigate airplanes with precision? How do we connect that aircraft to the ground so we can make smart environmental decisions? When you get that whole jigsaw puzzle together, I think there's some real gains that we can bring, you know, outside of the fuel environment. And if we look ahead, both of those domains, whether they're systems integration and flying airplanes efficiently, if we get to 2050, both of those are going to have something in the range of 8% fuel reductions in and of themselves. So, and that's not just unique to Collins. Partnering across industry, other suppliers would say the same. We just got to think smartly about 1 + 1 is greater than 2.
Thanks, Colin. I would like now to talk about batteries, as one of the solutions the industry may adopt is hybrid electric or electric propulsion systems, and especially in regional aviation. We are far from the performance that would make a hybrid or all-electric propulsion system doable or performant. How far are we? Arjen and then Stefan. And I'd like to have Eric commenting on this as well afterwards. So Arjen, to start with, maybe? How far from the performance we want?
Thierry, well, purely electric is a huge challenge. So we're talking about three main factors, which is the energy to weight ratio. We're talking about the rechargeability of batteries and the duration of batteries. And what we present to the market at the moment is that we could do a 10-seat aircraft with a 200-mile range, so it's really short, fully electric by 2035. And to do that, we need 3 times more chargeability, energy to weight, and life cycle than what we are looking today. So that is still assuming significant improvements of technologies to get to something small like a 10-seater. So the eVTOLs that we talk about, which are likely to enter into service the mid of this decade, those are 4 or 5 passenger vehicles. So that's where electric can play a role. 10 seats maybe in a slightly longer time frame. But the aircraft that we're talking about here and that we're all thinking about when we go on holiday, that's a giant leap. So you'll have to look at hybrid, and you run into the same challenges. So hybrid on smaller segment, we believe, is feasible, and you will be able to reduce fuel burn to some extent. But the bigger you go, also the more weight and the more systems you pull back on the aircraft. So even though on the ground it looks like you have a great solution, when you put it all on the aircraft and you put it all together, the on-wing effect also needs to be there. So it's going to take time to have bigger aircraft flying on hybrid. We believe up to 50 seats we're going to see hybrid applications, and then beyond that, also there we're going to see some more time frame to be required going forward.
Thank you. Stéphane, on battery performance?
Yes, you have seen in the Evo that we announced last week, we are talking about hybrid. Why we are talking about hybrid is because if we want to go for battery, I concur with the fact that a full electrical at TERA is just a dream, and it's not, you are just transporting battery, basically. Especially when we are talking about lithium-ion battery, which are, you have to contain the runaway, and it's very, very big weight on the aircraft. However, you can use the hybridization to reduce the size of the core engine. Because what is the idea? When you are sizing a core engine, you are sizing it for the whole envelope of the aircraft. Where you are sizing the engine is for the takeoff, on the climb, on the one engine in operative ceiling. If you manage to remove this 3 phase of flight, you can downsize your engine and then reduce the fuel consumption. And it goes with the SAF, because we know that the SAF will be difficult to produce. And this is one way as well to reduce the consumption of fuel. Because if you reduce the consumption of fuel, you can probably have more SAF, and it will be less expensive because the SAF will be expensive. So the idea is how you can use this technology and this hybridization in order to optimize your propulsion system. And this is one of the core things that we are looking at. And for sure, we need to have a step change in the battery. It's coming. There is solid-state battery that is coming up now, maturing, and for the end of the decade it will be ready. It will tackle the fact that to research rapidly solid state is okay. The number of cycles as well with solid state is improving a lot, because today with lithium-ion you have 2,000 cycles. For our aircraft we are doing 2,000 cycles a year, so you cannot change the battery every year. So we need a step change in the batteries themselves, and the solid state is something which is progressing quite fast. And we see that the battery technology, thanks to the big pull from the car manufacturer as well, the battery technology is evolving quite fast. And this is where we will hook on in order to do the hybridization, and then afterward progressively to be future-proof for the longer term, I would say, technology.
Thank you. Eric, would you like to pick up on that and maybe broaden that to new technologies that create an opportunity for new entrants, maybe in the supply chain?
Yeah, just I think it's interesting to watch the panel here, because we can see all of the difficulties. So one is purely electric, is we're far from there, apart from, I would say, general aviation. When we get into regional with airplane of the range of Embraer or ATR, we are in the hybrid. And to get the benefit of the hybrid, having led Rolls-Royce for quite some time, we all know that gas turbines are as efficient as they are big. And that's why, at the end of the day, that's why we ended up with the kind of configuration we have today, which is 2 engines per airplane. It's in terms of efficiency on gas turbine, it's by far the most efficient. Now, as rightly pointed, the problem when you move forward now, if you want to get the benefit of electric, you also need to add a number of engines. And we don't get the same problem with electric power as compared to gas turbine, because you can have a small electric motor which is as efficient as a big electric motor. So the problem is there. If you go to hybrid and you want to really make it affordable and really getting into massive efficiency levels, you need to move away from the gas turbine concept and move into what we call deported propulsion, which means more than 2 or 3 or 10 or 15 or 16 engines. Once you do that, you get into the electric, because it is, at the end of the day, even if you still have a gas turbine, the fact that you go through an hybrid motor and then batteries, you distribute electric power, then you get back to the challenge of certification, because you are in an electric motor certification, which is a completely different configuration as compared to what we have today and what we have been using for the last 40 or 50 years, where we've been very, very incremental on the way to certify and deliver new technologies. So I think that's exactly somewhere the paradigms we have to fix, which is to get to quicker, faster efficiency. We need to move away from that gas turbine installation, even if we keep a gas turbines today for hybrid application. But the core of the change is a pure electric core, and that gets a lot of challenges into certifications.
Thank you. Thank you. I'll have a couple more questions, starting with Luc, and then we'll have time for maybe 2 questions from the audience. I'm happy to lend my mic. At your end, given the number of technologies that may emerge, but we are not even sure which ones will emerge in the coming years, do you see a challenge in hiring new profiles? Are you hiring new profiles, and how are you doing that?
Yes, this is another challenge of the sector. It's not specific to us as regulator. I think it's what we discussed before we start the meeting. We have here to prepare, and industry said many times this morning that they want us to be ready. Of course, to be ready to understand how to certify, we need to get the high competence. Competencies in hydrogen, competencies in electric propulsion, competencies in cyber, in artificial intelligence, in drones, and so forth and so on. It was not so much available 5 years ago. So what we are now doing is really to organize that we can attract within the agency new competencies to special programs. And for that we have, of course, junior graduates. This is a very attractive program when we get really a new way of thinking, new way of looking at the technologies, which we need to bring to the senior engineers at the agency, and to build up the expertise. I mean, you are expecting us to have. But this is a big challenge, because I think we are in the middle of a crisis when to attract new employees. I think we are in competition with many sectors. And this sector, and the examples I was giving before, they are the same in other industry sectors. So is aviation still attracting enough when we compare to other automotive or IT? This is where we have to organize ourselves, and we have to do it. It's a challenge. It's a challenge. So, but we are doing it. We are also organizing that we have, when somebody is recruited, can be exposed to the new technologies. We have programs when we can have visitors, if you want, visiting staff going to see the technology and how industry is preparing, and that's the only way to do it. But it's a big challenge. We have another complication, of course, that the current technology is still there. So we have to cope with still maintaining sufficient level of resources and competencies on the current one when preparing the new one. And as regulator, we have to encompass also the cost of the agency on the certification, and this is where it's another challenge where we need to cope with. So that's yes, we do it, but it's not an easy thing, but we do it. So when we hope that we will be capable to staff at the level we are looking for. By the way, we are recruiting at EASA. Just an announcement to each of you.
Thank you very much, Luc. We have time for maybe 1 question from the audience. Just raise your hand if you have a question in mind. You have to raise your hand high, because I don't see very well because of the light in my face. Okay. Question on digitalization. The entire life cycle of an aircraft is being digitalized. How is that impacting the suppliers? So who would like to start? Pauline or Stefan? Or Colin? Go ahead.
Yeah, I'll take a run at that. Yeah, we call this a digital product life cycle, and I think this is going to be the thing that's going to transform, I think, everything we just talked about over the next decade. So if you think about from design and development through introduction to manufacturing, entry into service and support, having that digital thread throughout for suppliers of components, suppliers of systems, airframers, regulatory body. You think about systems definition, systems integration. These things take time. I many times with OEMs, we don't know what we don't know, right? We get into the work and we're defining an airplane, and to be able to go digitally rework that quickly, so speed and cost out is going to be a big deal. So we've seen people talk about 25% reductions in cost to design and development, 50% reductions in software, the time required to develop software, and the iterations will be reduced. And then from an overall labor efficiency standpoint on the regulatory side, if you can see this evolve digitally and simulate things quickly, I think we're all going to be in a much, much better place.
Thanks.
Yeah, I can complement on just going in your direction. When you look at every complex system, the burden is at the interfaces. All system, the issue is at interfaces. And the digital continuity is fundamental in order that effectively we streamline this exchange between all the players around the development. And the digitalization is key in the sense that from the beginning up to the end, having a digital, as we call a digital twin or a digital continuity is helping a lot first to develop because we manage properly the interfaces between the system people, the structure people, between the structure of suppliers, etc. It's fundamental to have this because it will help a lot. In the past, it was done by hand. It was done with paper. Here you can have the digitalization, which is helping. As well, using the 3D printing to do prototyping is essential as well to tackle this kind of point. And if I look at the end, I was talking about end-to-end. Even in service, having the digitalization is fundamental because you can know exactly what happened up front in terms of configuration. So when you have to support the aircraft, you know the data, you have all the data of the aircraft in service and you can manage it in service. And you can use as well artificial intelligence to look at the data you gathered in order effectively to support the fleet. We did that in Atera with the Smart Lander, for instance, which is a very good example where we took the thousand of landing we did in the past many years. We use the learning machine in order that effectively now when we have an event, based on all the past experience using this tool, digital tool, we can already have an information which is whether effectively we can put back the aircraft in service or we have to change the landing gear, etc., etc. So you see that the digitalization is something which is absolutely fundamental from the beginning up to the end and even in service.
Thank you very much, Stéphane. I have 1 minute for a burning question to Luc. What could artificial intelligence bring to future aircraft?
Many things, from design to production, operation and maintenance.
But are you ready to certify artificial intelligence?
We are preparing ourselves to certify. We are expecting the first product to be submitted to us. We have a roadmap. We have an aggressive roadmap. We have now we are getting this as a full program of the agency, and we are really getting the support of the non-aviation community to get us ready. So yes, we are really there. And we believe, I mean, it's something certainly we need to promote as soon as we can as a solutions for efficiency and for also getting the best integration in terms of data management. There is so much to get from data that we want to really to do that. And the example of also digital twinning, it's where we can probably make use of it as well. Before even we go for operations and maintenance. And the maintenance is another area where we get, by the volume of data we are getting, to go for more preventive, more anticipation in terms of maintenance, and therefore contribution to reduce the cost we are looking for. But we are preparing ourselves for when the product will come. Yeah.
Thank you very much. Thanks to all our panelists. Thanks for the dense discussion. Thanks for your attention.